All right, we're going to look at a method of factoring trinomials. Uh, I call it the diamond method, and it's one of the methods that's really helpful if you're a little rusty on doing factoring. So first, we'll just kind of do a couple diamond problems, and I'll set up the template for you. Okay, so you draw yourself a diamond. The top's going to be the product, and the bottom's going to be a sum. And what you're going to do is you're going to be given two numbers, or you'll have to find them from the polynomial. And you want to find two numbers. When I multiply them together, I get the top, and when I add them together, I get the sum. So we'll do an example here, okay? And let me see if I can. There we go. So I'm going to give you an example here where the top is 6 and the bottom is 5. So I'm looking for two numbers that I multiply together. They give me 6. And then when I add them, I get 5. Well, I can try 1 and 6. 1 times 6 is 6. 6 plus 1 is 7, which is not 5, so I don't want to use that one. However, if I try 2 and 3, 2 times 3 is 6. 2 plus 3 is 5, and that's my winning combination there. So 2 times 3 is 6, 2 plus 3 is 5. And that's kind of the idea with the diamond, and that's just a little skill that we'll use for factoring. So we'll put the template up, and I will set up a couple of diamond problems here. Okay, if you want, it might be a good idea to pause the video here and try these on your own. So for example, in the red there, I want two numbers that multiply together to give me 24. And when I add them together, I get 11. So again, if you want to pause, go ahead and try these. If you get stuck, that's okay. Maybe skip that one and do as many as you can. And then you can go ahead and continue the video once you've kind of worked through these. Okay, so I'm going to go ahead and put in all the solutions here. Well, if you got stuck on the green one there, you know, that's okay. It was a tricky one, but the rest of them should work just fine. So I'll briefly recap. 8 times 3 is 24. 8 plus 3 is 11. 6 times negative 3 is negative 18. 6 plus negative 3 is 3. Factors of 7. 7's prime, so the only combination you got is 7 and 1. And 7 plus 1 is 8. Now you might think, well, what if I did 7 and negative 1? Because 7 and negative 1 is 6. And that works, but however, 7 times negative 1 gives me negative 7. So that just unfortunately doesn't work. If we look at 36 and 13, 9 and 4 is going to work. And you can check the rest of these on your own. Hopefully they worked out pretty good. Okay. So let's actually use diamond to factor this. And I'm going to write in a bunch of stuff here. Okay, so let me talk about what's going on here. We're asked to factor 4y squared minus 11y plus 6. So the way this works is we're going to multiply the quadratic term times the constant, and that's going to give us the 24. The linear term is going to be the x or the y or whatever variable you have to the first power. Okay. And I'm asking myself, well, what two numbers multiply together to give me 24, and when I add them I get negative 11. So you go through your possibilities. So 24 is, possibility is 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't work. 6 does 6 and 4, but we'd already got 4 and 6, so that's where I would stop. And so what I'm doing here is I'm just writing out the factors: 1 and 24, and then I try 2, 2 and 12, then I try 3, 3 and 8, 4 and 6. Those all work. So I'm looking at is there a combination that I can add these numbers, and then I have to fiddle around with the negative signs at the end, such that when I multiply them, I'll get negative. When I multiply them, I get 24, and when I add them, I get negative 11. Well, 8 and 3 makes 24. When I add them, I get 11. So what if I make them both negative? Negative times negative is positive. That's good. And then the negative plus a negative is still a negative. So we're good there. Okay. And what happens is, maybe we'll do an orange here. We're going to split that middle term up into two pieces. So we're going to split up this negative 11y. We're going to split it up into the negative 8 and the negative 3y. And what I'm doing is I'm splitting it up into two to do something called factor by grouping. And if I have 4 terms and my instructions are to factor, usually I want to group the first 2 and the last 2. And when we do factoring by grouping, we're factoring out the greatest common factor. So we had a video that also did factoring the greatest common factor out. Okay, so let's go ahead and continue this. So if we group the first two, 4y squared and the minus 8y, they both have a 4 in common and they both have a y in common. Factoring that out, factoring the 4y out, I have 4y times y minus 2. Now if we do the second part, the 3y and the 6, they have a 3 in common. Now if I factor 3 out, it's not going to quite get me what I want. I'd have a negative y plus 2 inside. So we'd want to factor out a negative 3, so it switches this negative 3y into a positive y and this positive 6 into a negative 2. Okay. Now they both of these terms, the red and the purple, have a y minus 2 in common, so we're going to go ahead and we're going to factor that y minus 2 out. And our leftovers would be 4y minus 3. So we factor the y minus 2 out. That's the greatest common factor. What's left over is a 4y and a minus 3. And there we have everything grouped up. So I shouldn't have written here, but we can still do this okay. So the generic setup here is if I'm asked to if we're asked to factor ax squared plus bx plus c, the generic template would be a times c in the top, that's your product, and then the linear term in the bottom. And that's just the setup if you want to do this. There's different ways of factoring. This is kind of a good method to use if you're real rusty with factoring and you just want something that works for you. Okay, so let's do another example. 6x squared minus 7x minus 5. Okay. Oops, let's not give you the answers. Let's see if we can get it just there. We go. Okay. If you want to pause the video at this point in time, go ahead. Let me explain one thing, and then I'll give you a moment if you want to pause the video and try to do this on your own. So product is going to be 6 times negative 5, which is the negative 30. And the sum is going to be negative 7. So take a minute, see if you can find the factors of, just think of factors of 30, and then see which factors have a sum or difference of 7. So if you'd like to pause, go ahead and pause now, and once you've factored it or you get stuck, then you can keep going. Alright, so if you went ahead and paused, let's go ahead and finish this off. So factors of 30, well, 10 and 3. Let's see if that works. 10 and 3 makes 30, and they have a difference of 7. So I think I usually said sum, but you can also think of difference. Sum or difference. Once you found that, then you might have to fiddle around with the negative and the positive sign. So we need to make this a negative 10, and that does the job for us. Okay. All right. So what we go ahead and do is we rewrite, and we haven't changed anything. If I add the negative 10x and the 3x, I get back to the negative 7x. It's just a clever little trick to make this a little bit easier for you. And I have 4 terms, so usually we group the first 2 and the second 2, and we factor out the greatest common factor. So the first 2 have in common a 2 and an x. And when I factor the 2 and the x out, I have a 3x and a minus 5 left over. And the second folks, 3 and the 5, they just got 1 in common. So we're just going to go ahead and write 1 plus 1 times 3x minus 5. Okay. All right, one more step here. I'm looking at the red and the green. They both have a 3x minus 5. That's the greatest common factor. So we'll go ahead and factor that out. And we have 3x minus 5. And our leftovers are 2x plus 1. Okay. And let's see. Looks like we'll do another example. 36x cubed plus 8x squared minus 4x. Okay. Let's hide that 2 there. You didn't see that 2 there. So remember, the first thing to do. We've been factoring quadratics, and maybe I didn't mention that, but that's kind of usually what we want to do. First rule of thumb is always look for greatest common factor. Everything is even. 36, 18, and 4, they're all even. So I know 2 goes into it. So then I might want to check, does 3 go into them? Nope, 3 is not going to work with 4. Then I check 4. Well, 4 goes into 4, 4 goes into 36 evenly. Does 4 go into 18? Not quite. You get something that's not a whole number. So we can take 2 out, and you see how everyone has an x in common. We can also take out an x. So first thing we'll do is we'll factor out a 2 and an x. Okay. 2 times 18 is going to be 36. And then x times x squared will be x cubed. 2 times 9 is 18, and then x times x is x squared. And then 2x times 2 will give me the 4x. So our greatest common factor was 2x. Okay, now when you factor out the greatest common factor, usually it's just along for the ride. Let me get rid of this 30 from the previous problem. We'll get it out of the way here. Okay, this 2x out in front here, it's along for the ride. If we're doing some other stuff like finding bad points in the domain or solving it, then we would set that factor equal to 0 at the end. But right now it's just going to sit out there and look pretty. This time it's looking pretty with orange. So I'm going to factor the. I'm going to try to factor. I don't know if it'll work, but we're going to go ahead and look at this stuff inside here. So we'll ignore the 2x, and we're going to look at product of 18 and negative 2, which is negative 36. And I want the sum to be the linear term, which is 9. So what I'm doing here is I'm writing the factors of 36. 1 and 36, 2 and 18, 3 and 6, 4, 9, 6 and 6. Okay. And I'm just going to look at them. Do any of them have a difference of 9? Let's see. 1 and 36 doesn't work. 2 and 18, no. 6 and 3. Well, if I add them, I get 9, don't I? But when I multiply them, I get positive 36, so that's not going to work. 4 and 9 have a difference of 5. 6 and 6 have a difference of 0. So it doesn't look like we have any winning combinations. So what we're doing here is they're a little sneaky. they want us to factor it, and all we could do is get a greatest common factor of 2x out, and that's all we can do. Sometimes they can't. We can't go any further. All right, let's look at one more example. Say x squared plus 5x plus 6. Okay, why don't you try that one on your own? I'll let you, if you want to pause now, go ahead and pause. Okay, so if you tried this one probably wasn't too bad. This is a pretty common one, type of problem we would, ask you to do. Not specifically just factor this, but this would be part of a larger problem where you would be required to factor this. Notice the coefficient on the x squared is a 1. If it's a 1, then if you can figure out what the diamond is, you're almost home free. So if we look for factors of 6, we already did this one. It's 2 and 3 are going to be our winning combination. And you go through the process here of factoring out everything. All right, I'm going to go ahead and narrate what just happened here. We'll go ahead and also fill in. So our factors were 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. So that's where this 2x and the 3x came from. And notice that they add up to 5x, so we're good there. And then when we do grouping, we usually group the first 2 and the last 2. The first 2, the greatest common factor is the x. The second 2, the greatest common factor is 3. When we factor out the x for the first 2, we get x plus 2. When we factor the 3 out of the 3x plus 6, we get x plus 2. Greatest common factor of red and blue here is x plus 2, so we factor out the x plus 2. And we also and then our leftovers are the x plus 3. So a little trick here is, notice that the coefficient here was 1. If that's a 1, then your factors are going to be whatever solved your diamond. Okay. Now, just to give you an idea of when not to use this method is, let's say I wanted to factor 121x squared minus 169y squared, and they wanted us to factor this. If I multiply this, I'm going to have 121 times 169, and then what's the linear term? There is none. There's no just one xy, so if there is none, it's 0. So I'm going to have to look for factors of 121 times 169. It's going to be a large number. It's going to take me forever. This is a difference of squares. So that's one of the other videos. If you don't recognize this, it's going to make factoring this a little more difficult. Difference of squares. So you can go ahead and watch that YouTube video. If this is a little rusty, I will do some examples in class also. So this actually factors into 11x minus 13y and 11x plus 13y. All right.